So, hello and welcome to another episode of Interviews with Innovators. In this edition, my guest is Steven Stewart. I met Steven at the 2025 North American Honeybee Expo in Louisville, Kentucky, which was just a couple of weeks ago. He comes from a multi-generational family of commercial beekeepers going back to the 1800s, and he's a retired mechanical, electrical, and process engineer with impressive accomplishments under his belt. In this interview, Steven explains the concept and application of his newly introduced Hive Heater, which could just as easily be called a hive dryer. I hope you watch and listen to the very end and then share your thoughts. Who among us hasn't thought about warming a hive in winter? I'm Frederick Dunn, and this is The Way to Bee. Here's Steven. So, Steve, I want to welcome you to The Way to Bee. Thank you so much for introducing yourself to me at the North American Honeybee Expo back in Louisville, Kentucky this year. And you have a really fantastic innovation. I would like you to just take a moment and introduce yourself and talk to us about where you're located right now and what you do for a living. I understand you're in a winter location, which may not be where this product works the best. So, welcome.
Well, thank you. Yes, I'm in a winter location right now, but all my bees, 30 colonies, are back in Utah. And the new invention works really well there. They don't need it here in Mesa. It's going to be 70 degrees here today, but in Utah, it's really important. In fact, just to give a little bit of background, my dad was a commercial beekeeper, and my grandfather was a commercial beekeeper, and his grandfather was a commercial beekeeper back in the 1800s. So I grew up in the bees, and my dad taught me to work in the honey house. I ran an 8-frame extractor from the time I started at 12, and then eventually I ran the honey house, and during the summer, I worked in the bees and made all the nukes that we made lots of nukes. We make at least 500 to 1,000 a year. This was back in the heyday of beekeeping. This is before pesticides. Bees were easy to grow then and to produce. And so I've seen it all from when it was a heyday and when there were insects everywhere. They would cover the windshield of your car, which they don't do anymore because they're just not there. So I saw the easy day, and then the hard day came, and my dad sent me off to school, and because it was getting more difficult, beekeeping. And I went to school. I graduated, got a BS in food science, actually. Went to work for a food company in California by the name of Calcan, which is a Mars Incorporated company. I found out there that I had a talent I didn't know I had, and that was engineering. And I needed a little bit more money to live in LA. It's a big town versus little town in Utah. And I accepted or lobbied for an engineering job and found out it was fantastically fun to do. And so I did mechanical, electrical, and process engineering for the next 20 years for Mars Incorporated. I built plants and made machines that were installed all the way around the world in the Mars Incorporated. Most people don't know that they're the world's largest pet food manufacturer, but they manufacture candy as well, M&Ms, as Snickers. So I worked, when they had problems, I would help them out as well. I had a good career, so I retired at 50, and I wasn't just an engineer, Fred. For the last 12 years, since I built a plant, they didn't have anything to challenge me. They just said, do whatever you want. And so I made machines and innovated things that didn't exist. And I really enjoyed it. But I retired with an attitude, everything can be improved. And number two, nothing's impossible. So the first thing on my list when I retired was to fix the problem our family had forever, winter kill. It would kill minimum 18% of our bees every year. 18%, and that was in the good days. And it was getting harder, and more of them were dying. So by the time I had retired, all the bees were sold. I said, Dad, I want some bees. Well, they're sold, son. Well, that's not going to stop me. I'm going to have bees. And I worked on that problem. I had the funds and I threw everything I had with my new skill set at this problem. I thought, well, it's winter kill, winter's cold. We'll just do insulation that didn't exist back in my grandfather's day and dad's day, and we'll fix this problem. So I learned as an engineer, go to the extremes. You'll learn more at the extremes than anywhere else. So I made an igloo out of a beehive. I actually had an R50 on the sides, bottom, and an R70 to 80 on the top. And the bees would have to walk out 8 inches out of their entrance to get to the outside. Uh, and of course, I love electronics, so I put a temperature sensor in there, humidity sensor, and put the monitor on my desk, and I watched what happened. Well, it was the most surprising thing I'd ever seen. The beehive maintained an 84-degree temperature, except when it was 0 degrees outside, it dropped down to 83, maybe 82. And then as soon as it warm up, it go right back to 84. But the first week in February, no, it was February. It dropped down to 83, 82, 81, in the 80s, and it got into 70s over about a 4-day span. And I thought, this beehive's dying because they couldn't maintain their temperature. And so snowing outside and everything, I had a full frame of honey in my basement. I had some spare honey boxes, and I went outside and tore it apart. And it's snowing inside the hive, and I took a frame out and I put in a full frame inside it, and I thought, this is what you don't do in winter, but this is an emergency. And I put it all back together, and when I got myself all cleaned off, went back to my desk, and the temperature was 84 degrees again. But it was a failure of a test, Fred. Total failure. I had 3 hives like that, and they all had the same experience, and they had eaten themselves out of house and home. They had 2 full supers. It was a 3 hive, not just a 2. And I thought, that's not tenable. That's not the solution. That's not the answer. So I was kind of discouraged. I didn't know what to do next. Now, we're talking about a biological problem, not a physics problem or electrical problem or chemistry problem, because I minored in chemistry and I didn't know basically what to do next. The bees can't talk. If they could talk, they'd tell us. So I let it slide for about 10 years. I had kept my bees. I suffered the winter loss. To me, it was devastating. If you love your bees, it really hurts. You go in the spring, take off the lid, and they're not there, or they're dead, and you go, oh, that was a sucker punch to the gut. And you just feel awful. But I wasn't going to give it up. It was my heritage, and I just stayed with it. But in the meantime, I'm an innovator, and I wanted to innovate us. Let me back up just a minute. I wasn't equipped, Fred, to fix the problem. I really wasn't. It was outside of my realm of experience. So in the meantime, I went to another project, which was I wanted to grow my food in my backyard all year round, winter included, without heat. I knew greenhouses could be improved, so I was going to improve them, and I was going to do the impossible. And I actually succeeded in that. But I'm in the greenhouse one February, no, it was January day. It had been 0 degrees the night before. It was 20 degrees outside. It's 90 degrees in my greenhouse, and I'm just loving the sun. And I'm thinking, I've got 4 beehives behind my greenhouse that are probably dying. Maybe I can do something like this for my bees. That's when the light went on. It didn't take me an hour to put on my first Hive heater. I have a metal shop. I love to weld. I love everything to do with metal. And I put it on a beehive. And not just any beehive. I had this wild idea because I was losing so many bees in the winter. I'm going to try to keep one alive. I had a dead out, basically a half frame of bees, and they had requeened late in the spring. and I mean late in the fall, so they had no honey. So I made a bladder feeder I could put in the top. They could come up to feed when they want and then go back down. And I was trying to get them as much feed into them as I could, but then it got cold and they stopped coming up. So I thought, well, we'll see if they live. But when I got this idea, I'm going to put something of a greenhouse on my bees. I had the perfect hive to try it on. So it didn't take me but maybe a couple hours to make my first one, and I used greenhouse plastic. That didn't work so well. I put it on the hive and watched it for a couple of days, and they never came up to feed, so I knew that was a failure. So I redesigned it, made it more efficient in every way, acrylic, which is more clear, and made it so the airflow was more direct into the beehive. Put it on the first day, the sun came out, they came up to feed, and I was ecstatic. So I kept feeding them, and they kept getting stronger and stronger all winter. And the three beehives that were really strong behind them, all dead. They died. Yeah, winter's a killer in Utah. And I thought, well, I've got something here. I have to do something with this. I've just done the impossible dream. So, like I said, I love metal. I have all kinds of metal tools and cold saws and everything I needed, and I love to weld. So I made 25 aluminum heaters, hive heaters. I redesigned them yet again to make them more efficient. And I put them on 25 of my hives that year. And I knew I couldn't just put them on and see how they were doing if they made it through the spring. I wanted to do what I'd done with that dead out. I put one of those feeders, it looked like a bowl in the top, and I made a spacer with Duralar covering over it. It's clear as glass and a very strong plastic. And my lids on top, and so that I could take my lids off and I could watch and see how they're doing all winter long. And I only lost one hive that winter because they wouldn't come up to feed. And an autopsy later that spring, they didn't have a queen. They just lost the will to live. And I thought, oh God, this is a miracle. No one in my family, none of the generations of bees we've kept through the winter, we've never seen anything like this. So I've got a new device. I don't really understand how it works. I just know that the bees, I could watch them. They would walk around. They weren't clustered. They didn't seem stressed at all. But I was really worried. What about this device? It's a heater, and I could tell it was getting really hot, sometimes 90 degrees in the top of the hives, but the bees didn't seem to mind at all. But spring's coming, it gets warmer, and I'm worried about, am I going to cook my bees? Actually, I didn't realize the sun was changing its angle, so the solar heater wasn't heating as much as it was, but they were healthy. So I took it off right at the end of March because winter's pretty much done. And I'm used to feeding. We feed our bees. We always did. Spent tremendous amounts of money on sugar to feed bees. And so I was going to get my feeder on there. I wanted these off, and I was going to make sure if they needed feed, I was going to give it to them. That was 1st of March. We always do that. And I went to lift off the hives, the top hive, because I put them on a 2-hive box. You have to lift the top box off to get the heater off. Well, when I pick them up, they were heavy. It's like they hadn't eaten anything. That feed was up there, but not all of them ate the feed. In fact, I'd say only half of them would eat the feed, and the rest of them ignored it. So they're all heavy, and that was the first year, Fred, I'd never fed bees in the spring. I didn't need to. Was that an anomaly year? Yeah, it was not a real killer winter, but it was still a winter in Utah. So I decided I would do it again the following year, and I would write a patent about it, because if you're going to get something out, you have to kind of have a patent so a company will spend their money and it'll be protected if they go out and market it. I know nothing about marketing. That's a completely different field from engineering. And I did that, and I found some people that wanted to sell it, and they formed the company Hive, Honey Haven. And that year, if you go to the Honey Haven website, you can see that they came out to film my bees, and and we talked about it on that video that you can see on their website. But I was really afraid, Fred, I'd done something really, really bad, because that was the winter of all-time snow and cold in Utah, and there were only 2 months of sun just in November. 2 months, I mean, 2 days of sun in November, two of January or December, two in January, and two in February. So totally, they only had about 12 days of sunshine all winter long. And I had put water in those feeders instead of feed, and I'd given all my bees nosema really, really bad. So I had a 20% winter kill that year, which was still good, but most everybody lost all their bees because it was a horrible winter. It was still a win, but it wasn't. I repented. I'll never do that again. Put water in a hive in the winter. The next year, we're back to losing single-digit percentages of hives. It was a, it wasn't a hard winter, but it wasn't a good winter. But they weren't sick, and I lost single-digit percentages again. Now we're in the fourth year right now, and Fred, I mentioned this to a guy, Frank from Man Lake, and he says, "Oh, it's always my heavy hives that die." And I said, "I've experienced that before, because sometimes we have a fall and our bees get really heavy and they end up dead. And you'd think if they could produce honey because heat, because they've got all the honey they need, they wouldn't die. But in those hives, before my invention, they were moldy in the bottom. And I kind of came to the conclusion that when you had really, really cold days, all that mass of honey would get cold and keep them cold the rest of the winter. And so that this year is one of those really heavy years. When I put on the solar heater, we had what we call an Indian fall. That means they got an extra month to collect honey. It took all I had to lift those boxes. They were 60 pounds plus. And I'd take them off, put the hive heater on, and then put them back on. It was all I had of my strength to get them back on. And I knew they'd all be dead without the hive heater. So it's really a good experimental year, because, yeah, we've had last week temperatures, because I see the temperatures at home on my phone, 4 degrees, 3 degrees, and it was 13 degrees last night. Well, that doesn't hurt the bees if they can, the next day the sun comes out and warms the whole hive back up again. Fred, I'm not replacing queens like I used to. If I've got a good queen, I'll let her just stay there. And I've got queens 5 years old. I don't think they get stressed like they do when they're really cold all the time. Well, we go to the North American Bee Expo and to present the new product. And I've got this in the back of my mind. My first experiment failed because the bees ate themselves out of house and home. And this, they're not eating. So what's the mechanism behind all this? And why I was at the expo one night, I really pondered it over, and all I could think of is I never see any water or condensate or anything in my hives. I have that clear top. So I thought, I wonder if it has something to do with water. So I looked up that article I mentioned to you, where someone had gone through and done the calculation of respiration of the bees when they eat honey. They use oxygen, they generate CO2 and water. And it came out to be almost, for 40 pounds of honey for a winter, about 27 pounds approximately water is generated. So at our booth, we had 3 big gallons of water, which is almost not quite 27 pounds, and we put it in a box, a regular hive deep, and it filled almost all the volume. And I thought, this is a hive heater, but that's not what's making the bees survive. It must be that they can be dry. And if they're dry and that water's gone, because our beehives are enclosed, they have very little ventilation. And when I finally understood the amount of water that we're fighting, then it all became clear, because a wet bee just doesn't keep warm like a dry bee does. And so we called it a hive heater to begin with, but really it works by drying. I think it works by drying because after the sun quits shining, it gets cold again in the hive. But I think it gives the bees what they need, the ability to generate their heat more efficiently and stay warm because they're dry. And so it really should be a hive dryer, but hive heater slash dryer is, I think, how it works. And I used the example at the show that when we get out of the shower, the first thing we do, even if it was a hot shower, is dry off, because that water is evaporating and taking the heat off of our skin and cooling us down. We shouldn't feel cold because we're hot, but we do feel cold. And evaporation, they call it heat of vaporization, uh, it just sucks heat. And that's how I cool my greenhouse. They all cool that way with wet walls. Uh, when the water evaporates, it sucks the heat out and it's gone. So that's in a nutshell how it all happened. I was an engineer, but unequipped to solve this problem. Usually, most inventions come outside of the box of those people that are facing the problem most of the time. And someone with a clear perspective says, well, how about trying this? Because they have that in their experience. Well, as soon as I got the greenhouse built and functioning, then I realized I have the experience now to try something new on the bees. So that's been our experience. But full disclosure, Fred, you take a look at the map of the United States and the solar radiation that the map of the United States gets, the West gets the most. And so I don't think you're going to get 90-degree hives where you are, but being given that there's so much moisture in the hive, it gives another way for it to escape, even on cold days. And the hive heater looks like a condensing plate. It just drips water. And some people this year have thought, well, it's not working. It's going to put that water in my hive. Well, it's not. It is working. It's pulling where it's mostly concentrating, and it's condensing on those plates and taking that water out, and it's dripping out. At least it's getting rid of some water. And that's a big deal. That's a big deal when you can get rid of any water out of your hive. I like it, the idea, because there are beekeepers that realize that they put a small hole in the top, not very big hole, and it's got to be a strong hive because the warm air is just going to go right up and out. But it does take water out, and it does help them not have all the condensate. But this is different. It's not a free port for air to go right out of the hive. Hot air rises. It can't get out that way. It's stopped, but it does allow it to contact a cold place outside of the hive to condense some of that water. So it keeps warm air in the hive, because if you have a top box, it allows the top box to stay unventilated, if you will. But there's air that moves in there and it goes down, and if it hits that cold solar heater, it's going to condense the moisture. And then when the sun comes out, that dries off, and then it starts the drying process in the hive. Right now, we're working with the USPTO, the patent office, and they brought up solar heaters in the past. and they were with people that really didn't understand bees. They were designed to recirculate the air back from the heater into the hive. Well, you do that, you recirculate all the moisture back in, and you're not eliminating any of the moisture. And the moisture, I'm pretty sure, is what happens. You've got to get that out. They're all closed systems. And this is the first heater that's an open system. And by that, I mean it brings in fresh air and the moisture, heavier air, colder air is forced out the bottom. So there's a convection from outside to inside. And we're trying to convince them that we're still working with them. They're slower than molasses, but we think we may have our argument correct. And so we're still waiting on that. It's patent pending, but I'm excited about it. Now, any questions that you might have?
Well, and I want to thank you, by the way, because that was a very good run-on description that answered a lot of questions before I had a chance to ask them. So that's good. And I know that people are sitting because some people are just listening to this. So that's actually a very good description that you gave, but I'll bet they're having troubles visualizing it. Now, it behaves kind of like a plenum
Yeah.
to me. So I used to certify deep submersibles and I would inspect battery wells and things like that. So we counted on this passive air movement, right? So it would draw in from the low side of the outer bulkhead, go to the overhead, and then push out through the lower section from the inside of this well, and that would naturally create a heat exchange and an air exchange. So when I saw it there, and I hope people follow the links that we're going to put down in the video description so you can see exactly what this looks like, because as soon as I saw it, these principles are obvious. I also know why people are looking at it and thinking, oh no, that's just going to push cold air in at night. No, it won't, because it's almost like a snorkel where the low draw in is lower than the box that's warmed. So unless the air in that box is colder than the outside air, it's not going to move out.
That's right. It's
So
like an
it's
upside down water trap.
Yeah, it's beautiful in its simplicity, really. Once you see it, it becomes obvious what it does. The other thing is you hit on something right off the bat. I used to have these fantastic colonies that were just so big, and early on in my beekeeping, I thought I'm going to leave, a deep super of honey on there. And this colony, I'm just going to make so many splits in spring because they're just heavily populated. I had over 100 pounds of honey on there. And you did such a good job of describing exactly what happens when that honey retains the cold air, because your bees start the winter lower in the box. They're not up there on that honey to protect it from the condensation that forms and the chilling that forms above your cluster. And so when I saw what you were doing and the fact that this really, people should understand this thing has no electricity. This is a solar panel that you've put together that just draws heat from the sun, and it's black. The insert is, and now I understand it's aluminum,
Yeah.
right?
Yeah.
And so, and then again, the condensation on the outside, if it's going to move out, the warm air moves to cold surfaces, condenses outside the hive, and the vent is in the bottom of this thing. So once you see it, it seems obvious. That's
Yeah.
to me, once you see it. But if you've never thought of it, and this is why conceptually you've done such a great job here, because people don't think like that. I've seen the computer fans and all these thermostat controlled. I don't want anything to require electricity. I don't want
No.
anything to require circuitry. I don't want it to have to be turned on through my phone or something like that. And you did such a
Nope.
great job of describing this, and you remove it when the weather's warm.
Yep.
Like when spring comes along, it's just part of your spring maintenance that you would remove that insert, and you leave it keeps the upper. And here's the other thing, because there's another question that I have. A lot of people, those of us who have studied, anybody who went to Cornell or did the DICE lab, you'll understand that we need condensation inside the hive accessible to the bees for them to metabolize the honey and everything that was already described in your presentation. But this would still occur, condensation would still occur inside the hive, below the cluster where it belongs, and the bees still access moisture inside the hive. Is that correct?
That's correct.
Okay.
Yep.
So we're eliminating a big problem with the honey stores that are on in the winter in your top box because this goes under that top box. And the ability of the bees to move around on a warm day, just one warm day, because I think you said all you needed is a couple of sunny days a month or something. How,
Yeah, 2 days a month. Now we're at
2 days
high
a month.
elevation, so the radiation's quite high. But yeah, I was surprised on only 2 days a month. Now you get sunshine much more than that. We do usually, but except when records are set, and it was a beast of a winter. We'd never seen moisture like that in the Rocky Mountains.
Mhm.
And so it was just constant snowfall. But
But
you
there,
get some clear
yeah,
days,
so
it'll take care of it.
yeah, so there again, it seems kind of obvious. What if we had just could one day in the middle of winter when the sun hit, dry out that top box? Because there's a lasting benefit to that, even if on the following days we don't get the warmth benefit. But we've already dried it out, and now
Yeah.
that has do we understand how long they benefit from that single day of sun?
Well, I think I've disclosed to you all of our experience.
Okay.
And so I think as it goes forward, uh, I would like to see some universities test it
Hmm.
to see if there's how it really like you say the effects 3 or 4 days later, 5 days later.
Hmm.
Um, what's interesting me though, Fred, is they only needed a little bit of a boost.
Hmm.
They're quite capable.
Hmm.
They're quite capable insects. They just need a little bit of a boost because we put them in such an enclosure to get through it.
So now I have to ask, when you did your testing, did you split them? Like, did you have controls, like bees roughly the same colony size and everything else, with the only variation being this hive warmer?
Well, I have done a little bit of research. I decided I would weigh all my bees going into winter because after I realized they were surviving, uh, that I've had a winter where they had really bad fall, and the average now was 17 pounds. So some of them went into winter with only 10 pounds. And I was pretty discouraged. I told my wife, well, half of the bees are dead. They're just dead. There's no way they're going to make it through winter with 10 pounds of honey. So I thought, well, I'll use it as an experiment. I went back to Utah every month and weighed them at the first of the month, and they ate unbelievably little amount of honey. And that again just was not what I expected. And in fact, by the time the 1st of March came, when I usually feed bees, they were totally out. They were alive. And so some of them had gotten through with only 10 pounds of honey. And that just was not possible in my mind. In fact, I have a commercial beekeeper down. He has 4,000 hives in South Dakota, and he has a building up there, but he winters in Utah. And I had him over to look at it, and he says, well, I've got to have at least 50 pounds in my hives to make it when I put them in my building to get through winter. I said, Tom, I went, these hives made it with 10 pounds. He said, that can't happen. That can't happen. I said, Tom, I think that if this thing is working, well, it's been that was the third year. He said, call me back after the first year because I don't believe anything the first year. Well, I had good results the second and the third year, but it's really hard to change things. I asked him to put a dehumidifier in his big building, and thought it would help him all their bees survive with less stress, even though they're at a colder temperature without the moisture. If he could at least extract the moisture out of the environment, that would help tremendously. And then if he put a spacer in between his two boxes that would allow for free air movement to get the moisture out, he could probably, his bees would be much stronger in the spring and get more money at the almonds because they have noise meters, he told me, in his hives. And they pay him according to that, how many bees are in the hive and how much noise they make. So I think the water is a bigger problem than we've ever imagined. Uh, and if we tackle that, and this is one way to tackle it, our bees could do really well through winter. But then again, that thermal mass, you got to have that heated up now and again because it will kill the hive.
Mhm.
I've had it, and it really left me scratching my head when my heavy ones die. But I'm not worried anymore because they're going to stay warm. You were equipped better than I was to solve this problem because you had some experience with a plenum like this. Well, I had none because I was working with production machines and things like that. But this passive device, like I said, if I didn't have that greenhouse, if I hadn't made that, this solar heater wouldn't survive, wouldn't exist. It
Hmm.
wouldn't exist.
Very interesting. The other thing was, it's scalability wise, I was looking at small buildings thinking, wow, if I had one of those units that was 2 feet wide and 6 feet tall on the outside of this building, I would be pushing hot air into the upper portion of that building and cold air out through the bottom on these warm days.
Yeah.
Um, I can see other applications for this aside from beehives. I mean, once the principles are demonstrated so well, you know.
Well, it's a biological problem. The bees, geez, if they could talk, Fred, it'd solve all our problems.
Yep.
But they can't. And so we do trial and error more often than we like.
Hmm.
But I'd really like to see uh, some academics take it on, and because we always experience large winter losses in Utah, always, and they just got worse. And to have them almost disappear, there's got to be something there that someone's going to say, yes, this is absolutely tested. We've done it at the university. We've seen it happen. Uh, we need to get the word out because it's one of our major killers in the United States and in the north, in the cold regions.
Have you reached out to the Spivak lab in Minnesota or Cornell's Dice lab, or
Fred,
are you counting on me to talk to my friends? What are we doing?
never heard those names before, Fred.
Okay. All right.
I don't know anything about that. I came from food production
Yeah.
and so I like I said, I don't know those people exist.
Okay. Okay.
I don't know anybody.
This is going to be interesting. My only frustration with the whole thing is I'm not going to be able to test it here until next winter because we're already in midwinter here.
Yeah,
Um,
yeah.
but I am looking forward to trying this out myself next, when the next cold season comes. But I don't think you're going to have problems getting interest from a lot of undergrads, in a program, something like this.
Uh,
Because we do have northern climate research facilities for bees, and I'm going to be very curious about how that goes. Can I ask you some questions about your
sure.
background with the Mars company or Calican?
Uh-huh. Yeah.
Is there a system or some kind of now? What's the difference between systems engineering and production engineering? Because I've
Uh,
systems
yeah,
engineers.
process engineer goes through and actually understands the chemical composition of the food as it's processed and understands the parameters and limits that need to be set and then they also know how to make computers meet those demands. And so I started there and realized that the machines were defective and they weren't able to respond to what I wanted them to. So then I got into mechanical engineering. When I started, Fred, the computers were so large. I
Hmm.
mean, they weren't desktops, they were large, and the
Oh yeah.
boards were like 2 feet by 2 feet. And anyway, the electronics changed really, really fast. It got better, but the software, I had to write drivers for screens and everything like that. It got to be that was a job in itself, and it would change every 2 years. And I thought, well, I put all that work in, and it was lost in 2 years because new software comes out, and then you program it in a different way. So I transitioned into the mechanical part of it because nobody wants to work on these machines that are, well, I worked on machines with 400, 500 horsepower motors on them. They were huge and they're high pressure vessels and dangerous. And I had to change those because they were defective basically. And I knew they were defective. And some of the biggest chemical companies and biggest companies had tried to fix them. But I had the backing of Mars and I had this attitude I could do anything. And it took me about 3 to 4 years. And after that, oh geez, I was the golden boy. I
Huh.
couldn't I couldn't do any wrong. And that's when they asked me to put the guts in a plant in Mexico. And after that, I went from uh, manufacturing canned food because I started in California. They'd make about 1 million cans of dog food a day. And if they had a problem, it became 50,000 cans could be a problem because they had a problem in their manufacturing. And they didn't know who I was, and I didn't know what my skills were at the time, but I was able to fix that problem. So they put me in a research, and then they put me into a plant to fix their problems, which were huge. And I just loved engineering, and I've never had an engineering course in my life. And I've trained engineers from Russia to Western Europe on how to use neural networks. And because I found really quickly that neural networks worked really good on figuring out the mathematics of the machines that I wanted to control. And this was back in the late 80s. And they're just using them now to control cars, full self-driving. But I was using them way back then. So, Fred, I started on the truck dock smelling meats that were
Hmm.
just awful as an inspector. And when I finished my career there at Mars, uh, I knew all the owners personally, and I was a part of their family council once in Germany. They decided to meet there and invited me. And they didn't invite anybody from the US, but this lonely food scientist turned engineer from Utah. And I loved the Mars people. They were just magnificent people. And and so humble when they have a worldwide empire of companies. It humbled me, and I had the privilege of working for them, but they made special allowances for me because of well, I wanted to be challenged, and they allowed me to do that. And I can't say enough good about the Mars family
Hmm.
and how they treated their workers and how they treated me. I mean, I fell into that job. I graduated school and I had no money. Had a wife and we had nothing. And I, as a food scientist, went to LA, looked down at the classifieds of the LA Times and found 3 offerings for food scientists. And I said, I'll take the first one. I don't care what it is. I'll take the first one. And it was Calcan. And I never imagined I'd work for a pet food company, but it was the best thing ever. And I have machines that I designed, big ones, in from all over Asia, all over South America, all over Europe, Eastern and Western,
Hmm.
and North America, of course, and Canada. Because if you're not trained And I figured my strength was I wasn't trained to be an engineer to learn where the boxes were. And if you couldn't have an equation for it, it didn't exist. So I didn't have that training. There was no box for me. So I just didn't know what was not possible and decided to do the impossible. And it worked out really, really well for me. And I've had a blessed life, Fred.
Hmm.
There's no other way to put it. I've had a blessed life.
Okay, I'm going to ask you a random question. Are you a Mensa member?
A what member?
Mensa?
There's another word I don't know anything about.
Okay, all right. Because it's just people with high IQs join Mensa and carry a card just to prove that they're smart. But since you're not a member, it doesn't matter.
Well, now that you mention it, our company would do personality profiles on their engineers, and they'd do it like every other year. And ISTJ is my personality profile. And there's another person with the same personality profile I have. And I was the only one in the company who had that personality profile. And I kind of knew that I was different. I knew I had Asperger's. Well, Elon Musk has the ISTJ personality profile, Myers-Briggs, and he has Asperger's.
Mhm.
So when it comes to physical things and engineering, like he spends 80-90% of his time just doing engineering. People I don't understand, Fred, but as far as physics and physical things, they speak to me.
Hmm.
But I'm as dumb as mud when it comes to people. I'm dumber than
Well, I wouldn't say it's dumb. You may not be aware of people in the same way that others are, but it's not
I have no
intelligent.
awareness. I have
Okay.
no awareness.
I'm getting
I,
a lot more out of this interview than I ever thought. Okay.
well,
It's, it's very
uh,
interesting.
let me give you one more tidbit that my bees, when they started not to die, and I knew how to handle a pesticide problem, because I had a neighbor that spent lots of money on pesticides, but I worked with him, got that solved. I started making money selling my honey at the market. Now I've been retired for, like I said, 17 years, so it's kind of nice. And I came across a discovery which I never thought I would. And I'm kind of giving you the bank away here because my honey's different than other honeys that are raised in Utah. They don't taste the same. And like I told you, I was raised in the warehouse extracting honey. I've tasted honey so good, and I've tasted honey so bad, you'd have to lick the bottom of your shoes to get the taste out of your mouth. And black as tar. And my grandfather used to send it to Germany, and they made beer out of it. And I thought, gee, I couldn't even stomach it. And anyway, I'd tasted a lot of honey, but I made a modification to my bees, and I just did it to keep them cooler in the summer. I built stands off the ground, so I put in a screen bottom, Fred, and I put in big holes at the top. So I had uh, good ventilation. Now, I was in beekeeping before the days of forklifts lifting hives around. All our hives had to be lifted by hand. And when you would go out to the beehive at night, in the bees at night to move them, some nights they were just humming like crazy. They'd just be the
Mm.
hives would be humming and alive. And Dad told me, well, they're trying to fan the honey. They're trying to decrease the moisture in the honey. But it was loud. You could hear them. They're working their guts off to take the moisture out of the honey. So I decided from my childhood, I remembered that I would lift my bees up, put a screen bottom underneath them with big holes at the top to help them so that they didn't have to work so hard to lower the moisture in the honey. Well, that year, my honey tasted so good, I couldn't believe what I was tasting. And I thought, wow, this was an exceptional year. And then the next year, it was the same way. And I thought, Okay, stupid, what have you done to your bees? Why does this honey taste like this? And then I realized it probably had to do with the ventilation. And I thought, well, okay, this is good because I'm not talking just a little bit of taste difference, it's a lot. So I have a neighbor that uh, lives a quarter mile away from me, and he likes to use my extractor and my equipment. And he has like five colonies, 5 to 10, likes to run. Well, when he extracts in my garage versus when I extract, my wife will walk through the garage to get into the house, and she goes, when he extracts, and he's a good friend, I like him, but she goes, it smells like dog poop in here. And she says, why doesn't it smell like that when you're extracting? Well, because I have that ventilation all the time, the bee odor isn't getting into my honey. That's the only thing I can think of.
Hmm.
And if by chance they put enough pollinization or propolization over the screen and they block a lot of it off, that honey in that hive doesn't taste good, and I don't even like to sell it.
Hmm.
And there's another thing I learned, that if you want to sell at a farmer's market, you've got to break the habit of harvesting your honey one time during the year. You start harvesting when the market starts, and you harvest every week, some every week, enough to sell. And so you're actually taking honey off, and it's really fresh. It doesn't have any odors in it at all. And they line up to buy my honey every year, and I'm selling a lot of it for a lot of money because its taste is selling it. And it all had to do with ventilation. And all I can say is it's exceptional honey. Now, if my competitors at the market hear this, I'm in trouble, Fred. I'm in trouble.
Yes.
Okay, because last year I sold 1,200, almost 1,300 pounds of honey. And you sell that at $10 a pound, uh, it adds up. And I have no trouble moving that. And I just sell it at the town next to me, and it's not a large city by any means, but it's enough to move it. And I wish I had more. Maybe this year I'll be having some more than I had the previous years. Because last year I learned another trick. You can teach an old dog tricks. I requeen my bees with press-in cages, and I'd never used them before. And when I tried to replace the queen, it was a 50-50, and they really never did good. So you learn a lot on YouTube. I saw a guy using press-in cages to fix a drone layer, and he fixed it. And I thought, dang, I'm going to try that. I had 100% success, except for two queens. They let her die because I had mistakenly left the queens. And I thought I'd taken them out, but their queens were still there. But all the others thrived. Oh, well, geez. I'm as happy as can be. So I'll even have more honey this year. So that's my secret. If you ventilate during the summer, your honey's going to be a lot better tasting in the fall. But it takes a lot of ventilation to do that. Now I have two big 1-inch holes at the top. They don't use them for entrances. I don't know why. But that convection going through the hive, oh, I have so many people tell me I can't eat other honey. You've just wasted me. I can't eat other honey now. I have to eat yours.
So you're creating addicts.
Yeah, yeah, I am.
So what do you think the primary floral source is for your bees there?
Good question. We have an alfalfa hill field behind us. I have 480-foot rows of blackberries. Uh, there's a lot of weeds, I guess, because I'm not right in the middle of the city. And there's raspberry patch that I have bees at. It's just 5 houses down, and they have an acre of it's a U pick. They come and pick raspberries, and so that's basically what's in my area. But
And you're thinking that the floral source for your friend who has the stinky, unpalatable honey
oh, it's the same.
is the same.
Yeah, it's actually not a quarter of a mile. It might be an eighth. Actually, you can walk to his house in 5 minutes. And his bees are behind his place, and mine are behind my place. I have a lot behind. I have 13 hives on my place, and without a doubt. And he'll come to me. I don't say anything. He says, "My honey doesn't taste like yours." And I said, "Clark, all you got to do is put a screen bottom in the bottom and put big holes at the top, and it'll taste just like mine."
Mhm.
He goes, "Yeah, I got to do that, but
But he won't do it.
no."
Try it. I would like to see him try it with half his hives and see if there's a
Yeah.
flavor distant difference just in that alone. Um, but it's
But when I
interesting,
have a hive blocked off, Fred, they don't like the screen. I'll tell you straight up, they don't like it. They'll try and fill it all in.
right?
But if one's successful, I really can't stomach the honey.
Hmm.
I've been spoiled. I've been
Yep.
spoiled. So
Now,
you can pass that along. That's at the higher elevations. We're at 4,700 feet. And maybe that has something to do with it. I don't know.
yeah, we're at 1,300 feet where I am. So let's recap a little bit, Steve, if you would. The website where people can find this hive dryer slant hive heater is at honeyhavensupply.com.
That's correct. Yep.
And are they currently running any specials or anything that people should know about
They did at the show.
at the
Um,
show?
yeah, it's good to come to the show. A lot of people get specials at the show. And I guess that's why a lot of people show up. They sold out very quickly this last fall.
Mhm.
It was more than they ever imagined. So they're going to 3 times their production to get it up, but it takes time to make them. And so they won't underestimate next year.
So what's the availability through the website? They're in stock?
No, they're not. They won't be till late spring.
Okay. But they'll accept pre-orders or how does that
Oh
work?
yeah, they'll
Okay.
take pre-orders. They will take pre-orders. It's I guess it's a good problem to have. Not well underestimating the market, but they'll try and get that fixed for next year. But it might be really hard after somebody watches your podcast and the word gets out.
Mhm.
And you mentioned to your friends at these universities and at these places you mentioned where they do research.
Mhm.
Well, I think something new like that would make a great undergraduate or a graduate project.
Yep,
Uh,
I agree. Okay, I have another question for you. Concept. These are for Langstroth hives, so you have them for 8 and 10 frame Langstroth configurations. Here's my thought. Long Langstroth horizontal hive, if you had a single entrance at the, let's say the southeast corner, and you were able to rig one of these to fit at the opposite end of a horizontal hive, it seems to me that it would have a similar positive effect that it would push and dry that air from the deepest recesses out through that single entrance at the opposite end. What do you think?
Physics is physics, Fred. You can do it on any size of box you want. You just have to have I'm not familiar with the hive. I don't know where the entrance is. If it's lower, it
Hmm.
could work.
Yep.
If it's lower, it could work.
Okay.
And it could set up a convection current from the outside to the
Yep.
inside and back to the outside. There's nothing special about the physics here. It's just
Hmm.
really simple. And it could revolutionize those hives as well
Hmm.
because they produce water. they have water
Oh,
problems. It doesn't get
absolutely. And
better.
it was another thought that I had looking at it is that we might have a solution to a moisture problem in these larger horizontal configurations um, as well. So
Yeah.
I think there's a lot of potential here.
Yeah, there's another graduate degree project uh, which could really help the bee industry. Fred, my friend who's done commercial beekeeping forever, he's turned it over to his son now because, well, we're all getting older. Um, he has losses in his building, South Dakota. Even though he puts his bees in there, there are losses. And they can lose 30% of their bees. And I don't know if that's normal for other commercial beekeepers. I don't know. But I've heard that they try and put bees in potato pits. When the potatoes are gone, they can put the bees in there and they have the same amount of losses in those situations as well. I'm not experiencing those types of losses.
Mhm.
And even if, Fred, it was a kind of a situation where, yeah, you're getting a lot of solar radiation at your elevation or in the map of the United States, it's really good for the winter. It's still a better thing to maybe move your bees and keep them outside instead of have these buildings
Mhm.
that you've got to maintain and they're expensive to maintain the temperature, everything right. And then you got to take and put them in, take them out for a cleansing flight, put them back in and all this. Might be easier just to put a commercial type of solar heater on the hive and let them go at it. If they don't eat as much and they are all stronger in the spring, it
Mhm.
might make these buildings obsolete. They're going to head to the almonds anyway, Fred. They're halfway there if they moved them to the west. If that's what the hive heater demands, I don't know if it does or not. If it doesn't, then they can use it anywhere. But I would, for the bees' sake, I think you'd do something that makes the most economic sense and keeps your bees healthier than clustered the whole time in a building because they have to keep them at 40, 41, or 42 degrees. I'm not sure what it is.
Right. Yeah. I believe they found that 41 degrees Fahrenheit had the longest life expectancy. Yeah.
Yeah. But I still think that clustering, Fred, is a survival mechanism. I know it is. It's a survival mechanism. And if you can relieve them out of that survival mechanism, you'll take stress off of them.
Mhm.
Even if it's cold outside, it doesn't need to be cold inside if it's warm. So I is so new, Fred. I think there can be a lot of graduate degree projects here from universities that do things like this. I think they're going to find out that they may obsolete some of the current ways we keep commercial bees alive.
Mhm.
If they duplicate the same thing that I've had the same experience, oh geez, it'd be great.
Now, since you've implemented this hive heater, what are your losses after winter?
After winter, uh, they're single digits. There were 5% that first year, 20% the year after that I told you was historic year, and I gave them 100% Nosema. Those hives that died were so bad inside, I just threw them away. There's no way I could clean them.
And those are the
And
hives, just to recap, you had put water inside those.
water in
Yeah.
the inside them.
What did you think you were putting in? Sugar syrup?
No, I just thought they'd like to drink now and again.
Oh, okay. All right.
Well, okay. See, Fred, you know a lot more than I do, okay, about that kind of thing. So, but I learned from Hard Knocks.
Mhm.
And then the next year after that, I was back to about 5%. Now, some of the hives that make it are, they were weak going into fall. They're still weak in the spring, but they're alive. Those are prime candidates to requeen immediately
Mhm.
and not have to buy a new hive or a new nuc or something like that. You can just requeen them and the hive can go right off.
Mhm.
So that's what I plan to do. I have I have a couple of hives that are really, really weak. They didn't get any honey. If they're still alive when I go home, I'll be lucky because they only had less than 10 pounds of honey in them. But they got a hive heater on them. Last I checked, which was the first of the month, they were still alive, and I didn't expect that. But if they get through, I'll give them a new queen, and they'll get a new lease on life.
Mhm.
I don't hesitate to give queens anymore with a press-in cage. But I found the queen was laying under the cage, and when she starts laying, they're not going to kill the laying queen.
Mhm. So that's your queen introduction method when you're requeening a colony.
Yeah, even this year I went out and I had a mean queen, and I had some that were weak, and I'm not tolerating a mean queen, so I just squeezed her and put another one in a press-in cage immediately, and all on three others the same way, two or three, no, two others with them. There were three total right then, and they all took,
Mhm.
and they were all good hives.
Mhm.
And I was amazed because when I pulled up the frame, you put the press-in queen cage on. I didn't even take the queens out of the cage. I just popped the lid, put them under the cage as well, the press-in cage, and I tied some twine around the frame so they couldn't, it wouldn't fall out. And when I took them off, I could see eggs because I made them about that big. I wanted them to have some room to lay. And she lay. She'd put 3 or 4 eggs in. She just wanted to lay.
Mhm.
And they just accept them. I don't know if they can smell it or what, but they know she's a queen worth keeping, even though I just killed their old one.
Mhm.
But I did wait 5 days before I let them out.
Mhm.
And I'm so happy with that.
Hmm.
I really like that method.
Well, it's all super interesting, and I want to thank you for sharing with us today. And do you
Yeah.
have any closing thoughts or statements you'd like to make?
Yeah, I would like to add this. When you get to my age, you really don't care about if you've got your needs, your life's been set. Okay. I'm not looking to make money. I'm looking to make a difference. That's the only thing that happens that really matters when you get older. And if I can help the bee industry, oh, that would be my ultimate dream. And so I'm hoping that it goes from here and kind of, I don't know how to say, it gives a value to my life in
Mhm.
that way.
Mhm.
That's the only thing I'm interested in, and I'm deeply appreciative of you looking into it
Mhm.
and I guess exposing it to the world.
Mhm.
That's all I that's all I
It's
want to say.
it's an absolute pleasure, and I want to thank you for coming on. I think there's going to be a lot of people interested in this. So thanks a lot, Steve.
Oh, thanks, Fred.
Yep. And that wraps up another edition of Interviews with Innovators. I hope you'll take a moment to visit the video description and follow the links provided there for more information and resources. I want to thank you for watching or listening to my conversation with Steven Stewart, and I look forward to reading your comments. If you enjoy the content I produce, I invite you to subscribe to my channel so you won't miss a single video or podcast. I'm Frederick Dunn, and this has been The Way to Be.